Okay, how's everybody doing today? Sounds good. Okay, tired. Yes. Couple things. Of course, the big item. Yes, for us. Sure. All right. Big item coming up on Friday. What's happening? Okay, you've got your exam. What will it cover? Okay, so there will be some graphing of the trig functions on there. But mostly, more than anything else, what have we been doing recently? The inverses of the trig functions. Okay, so you want to be, please take the time to go ahead and look over the material. We are not going to have that many grades left in the semester. Basically, after this week, you've only got 2 weeks left, and then we're done. We got the test, we got the focus activities, which hopefully will be a good grade. Probably get another quiz grade in next week over this material, maybe if we can fit it in. I'd like to see if we can get the homework in before the end of the semester. That depends on how long it takes us to get through the material, so we'll see. So beyond that, there's not going to be a whole lot happening. So please, if you have questions, come on in. Let me help you. Definitely be paying attention to the final grades, trying to make those as high as you possibly can. Now, speaking of the test, has anybody had the opportunity to go watch that video? Okay, so only a couple people. You still got a couple days left. Remember, there is a problem on the test, just like that one I discussed in the video, and there's also another problem for you to go ahead and practice. Please take advantage of that, especially if your grade is low. We need to make sure that grade is as high as possible, so take the time to go ahead and look it over. All right, well, we don't have anything else to take care of today, so we can go ahead and get right to the lesson. I provided you with a list of these yesterday, but these are all the trig identities that we're going to become familiar with. They're broken down into certain categories. We have the reciprocals, ratio and quotient, the Pythagorean identities. Now, these are probably going to be the most important to you than all the other ones. Okay, you're definitely going to want to know those. We also have even and odd functions and what we refer to as cofunctions. And I've actually mentioned that word several times over the last couple of months, but today we're actually going to see what that means. So today is an introduction. We are going to take the last part of class to go ahead and start simplifying these expressions using the identities, but we want to go through, talk about the identities, take a few at random, prove them, kind of talk about them. Okay, so let's start. There are 6 reciprocal identities. Okay, so sine of theta equals 1 over cosecant of theta, and you'll notice there's already one change. From what I just had listed, all of those had x, all of these have theta. So the variable itself has nothing to do with the identity. You can even see alpha, beta in there. The identity is still going to hold true, so it may switch from time to time. Okay, so cosecant of theta is 1 over sine of theta, and the same applies to the rest of them. Okay, so let's go ahead and take one of these and prove it. Stephanie, which of those 6 would you like me to prove? Cosecant equals 1 over sine. Okay, so cosecant of theta equals 1 over sine of theta. And I'm not going to go ahead and prove all of these because in a lot of cases when I prove one, you're going to be able to see how you can prove the others very easily. It's going to follow the same process. So here's the thing about proofs. You can't use the rule itself to prove the rule. You have to use other rules that have already been established to help you with what you're doing here. So if I'm trying to show this reciprocal, well, I can't say just because they're reciprocals, okay? Now, some proofs are going to be really quick, very short, not a whole lot to them, as this one will be. And granted, there are proofs out there that are very long and time-consuming. Okay, we are going to start looking at some larger proofs when we get to the second semester, but we're going to start off kind of small. Let's think about the ratios in terms of x, y, and r. Miriam, what's the ratio for cosecant? Okay, so what is that in terms of the variables x, y, and r? So r over y. So I'm going to replace cosecant of theta with its ratio r over y. And see, we'd already previously talked about these. All right. So I'm not using the rule, I'm using the ratios. Raphael, what was sine? Okay, so in terms of the variables, okay, y over r, right? So I've replaced the two trig functions with their ratios. And what do we like to do when we're dividing by a fraction? Yeah, we multiply by its reciprocal. Okay, so I'm going to flip this guy up right here. So this is going to be r over y is equal to 1 times r over y. But anything times 1 remains the same. And so we know that identity is true. Okay. So could I do the same thing for the other 5? Oh, yeah, I can just replace each one of those with their ratios, get a common statement. Easy, easy. Okay, good. Those are the reciprocals. Okay. There are 2 ratio or quotient identities. What's one of them that I had listed on your paper? There's only 2 of these. One of them starts with a T. Tangent. Okay, there we go. One of the identities we saw yesterday on the paper I gave you, tangent of theta is equal to sine of theta divided by cosine of theta. And there was another one. Okay, cotangent. So cotangent of theta, we can actually say that's cosine over sine. Now, in order to prove these identities, we're going to use the same strategy we did just a moment ago. We're going to rewrite them in terms of their ratios using x, y, and r. So, Ethan, what do you like? Tangent or cotangent? Which one? Tangent? Okay. So let's see. What is tangent's ratio? Okay, so tangent of theta is y over x equals. Now, sine of theta, we just saw that was y over r. And what's cosine of theta? X over r. Okay, so I'm dividing by a fraction, so I'm going to multiply by the reciprocal. So y over x is equal to y over r times r over x. And what do you notice? The r's cancel. So I do have y over x equals y over x. So there's my quotient identity, or sometimes they're referred to as a ratio. Okay. Could you solve the other one very similar? Yeah, you'll just replace them with their ratios and show that they are equivalent. Okay, questions on the ratio quotients? Now let's get to the ones that are going to be the most important to you. The Pythagorean identities. There were 3 of these. Okay, the first one, sine squared. This time I'll go back to x. So sine squared of x plus cosine squared of x is equal to 1. Then I also had 1 plus tangent squared of x. What did that equal? That equaled secant squared. And then we had 1 plus cotangent squared of x equals what? Cosecant squared of x. Yes. All right. Now, I'm actually going to go ahead and prove a couple of these because I always want you to show you when you're dealing with a proof, is there going to be more than one way to do it? Yes, you don't have to follow the same pattern every single time. Okay. Now, let's go ahead and start with sine squared of x plus cosine squared of x equals 1. I want to prove to you that this is true. Now, before we go ahead and do this, you remember I mentioned a few moments ago, we can't use the rule itself, so I have to use rules and theorems that we've already been using, ones that have already been established. So let's say we have in quadrant 1, let's say we have a terminal side, connect it to my x-axis just like we always do. And let's say we have theta, my reference angle. Okay. Well, we know the horizontal is x, vertical is y, and the radius r, or the hypotenuse. Okay. So Xavier, what's the relationship between x, y, and r?
What do you like?
Is there a certain equation I can use to relate them all? A theorem, perhaps.
Pythagorean?
Okay, so that would be x squared plus... There you go. So x squared plus y squared equals r squared, right? Now, we're not proving that, but we're going to use that to help me with this one. Okay, so we're going to put him to the side for just a second. We wrote him out for a reason. Now, sine squared of x plus cosine squared of x equals 1. Let's go back to the ratios. We said that sine was what over what? It's y over r, right? But see, here's the thing. We have sine squared. So whatever I'm going to replace sine with, I have to square it. So this would be y over r squared. See, I'm replacing the trig function, not the operation that's happening to the trig function. Plus, what am I going to put in place of cosine squared? X over r squared. Okay, and that equals 1. All right, so think back to Algebra 2 when you had your exponent rules. If I have a ratio quantity and I square it, what would that be? Like x over, or excuse me, y over r, that quantity squared. Wild guess. Anybody? What does it mean to square something? You multiply it by itself, right? So y over r squared would be y over r times y over r, so I would get y squared over r squared. Plus, what would x over r quantity squared be? X squared over r squared is equal to 1. Okay. Now, do you notice anything?
Yep.
They have a common denominator, so I can pull these together. I can put them both over r squared. That's y squared plus x squared equals 1. Now do we see why I brought up the Pythagorean theorem? Okay. What is x squared plus y squared equal? It equals r squared, right? So can't I substitute r squared for y squared plus x squared? Bless you. So this would be r squared over r squared, which is equal to 1. But what's anything divided by itself? So 1 equals 1. So I showed that was a equivalent statement. So I know that sine squared plus cosine squared should equal 1. Okay, does that make sense? Okay. Now, I want to go ahead and show you another one of these, but I don't want to go ahead and use a ratio. Let's go to the tangent squared one. So 1 plus tangent squared of x equals secant squared of x. Now, could I go ahead and replace tangent and secant with their ratios and do something very similar to what I just did with the previous? To show that it's true? Could I do that? I heard a yes. Thank you. Yes, you could do that if you wanted to. But I want to show you another method. In order to prove this one, I'm going to go ahead and use the identity that we just proved. Remember, you can't use the rule itself to prove the rule, but you can use others to prove the rule that you have. So what can I do to sine squared of x plus cosine squared of x is equal to 1 to show that this rule is true? Because it's an equation, I can manipulate all 3 of the values, the 3 quantities that I have here. Sine squared, cosine squared, and 1. Let's take all 3 of them and divide by cosine squared. That is an x right there. Okay. Now, does any part of this look familiar? Okay. We just had an identity a moment ago. What is sine over cosine? That's tangent, right? So if sine over cosine is tangent, what's sine squared over cosine squared? That would be tangent squared. Plus cosine squared over cosine squared. 1 equals. Now, one of the first things we looked at was the reciprocal identity. So what trig function equals 1 over cosine? Secant. So 1 over cosine squared would equal secant squared. And that was the rule that I was trying to prove. And we know that's correct because I'd already proven sine squared plus cosine squared equals 1. Okay, questions? So if you wanted to go ahead and prove the last one there, you could plug in the ratios like we originally did, or you could manipulate sine squared plus cosine squared equals 1 to get that. In fact, what would you have to divide by this time? You'd have to divide by just sine? Sine what? Sine squared. There we go. Okay, good. Good. All right. Next category, we've got 6 even and odd identities, and I've already broken them up into 2 subcategories for you. There are only 2 even trig functions. The rest of them, the 4, are going to be odd. So what does it mean if we have an even function? What is that telling me about the graph? What's his symmetry? Bless you. Okay. What's that done? Oh, no, that's odd. Oh, no, even. There you go. Even means it's symmetrical with the y-axis. So if I fold it on the y-axis, the 2 parts are going to come together perfectly. If it's odd, okay, that's a rotation 180 degrees about the origin. I should be able to get the exact same thing. Does anybody else need the key for the assignment? Has anybody not gotten it yet? Juan, didn't I give it to you first? Okay. Anybody else? All right. Okay, so I'm going to go ahead and show you one of these graphically. In fact, let's go ahead and take the first odd function. Sine of negative theta equals negative sine of theta. Sine of negative theta equals negative sine of theta. So some of these we're not going to do algebraically. I'm going to go ahead and show you graphically because that is the best way to see it. So let's start with just a graph of sine. Where does sine begin? With a 0 or a maximum? Always with a 0. Okay, so let me go ahead and write this out. We're starting with a 0, so let's say that's pi over 2. This will be pi, 3 pi over 2, 2 pi. And then we have negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. There we go. So then we have a maximum and a minimum. So then we have a maximum 0, minimum 0. And then we can go in the other direction. Okay. There we go. So if I were to connect these with a smooth curve, there we go. So there's the graph of sine. There's the parent. Okay, sine of x. Now, when you're talking about a transformation and you're looking at a reflection, if the negative is inside, that reflects it with what? Would that be the y-axis or the x-axis? Okay, I heard x, I heard y. It is the y-axis. If the negative is on theta or if it's on x or whatever your variable has to be, it's going to be symmetric with the y-axis. Okay, so what if the negative is on the outside, the function itself? How do I reflect it? That's with the x-axis. Okay. So let's go ahead and choose one of these. All right. Let's say I want to go ahead and show this transformation right here, sine of negative theta. So I'm going to take this graph that I have, and I'm just going to reflect it across the y-axis. So this portion on the right, I'm going to reflect him over, and this one here, I'm going to reflect him over as well. Okay, imagine I could just fold the screen right there on the y-axis. So,
teachers, I'm sorry for the interruption. Freshman boys B team basketball. You've had a change of plans. You guys are meeting in the cafeteria today. Again, freshman boys B team basketball. You guys are meeting in the cafeteria today during 8th period. Thank you.
okay, well there's the reflection. I did it in red. I went ahead and highlighted it. So I just took the right side, folded it over. I took the left side, folded it over, and there we go. Is everybody okay with that? Now let's go ahead and reflect the original graph with the x-axis. So I'm just going to take the top, I'm going to fold it down, I'm going to take the bottom and fold it up. But do you notice anything? Whether you reflect it with the x-axis or the y-axis, it's going to result in the exact same graph, the one that I drew in red. So that's why we have this identity. Sine of negative theta equals negative sine of theta. Now, if you were to look at the symmetry of the other graphs with respect to the identity, you're going to see that you can do these as well for even and odd. Remember, even is only with the y-axis. Here, the odds are going to be both the y and the x. Is everybody okay with that? Pretty easy? Okay. So those are my even and odd. And I believe this is our last category, because after this we get to problems. Yes? we have 6 co-function identities. All right. So you'll notice there's a pattern here. Pi over 2 minus x repeats over and over and over and over and over again. Okay, the only thing here is being able to remember which trig functions are co-functions. Sine and cosine are co-functions. Okay. Then tangent and cotangent are co-functions. And secant and cosecant are going to be co-functions. That means if I take the graph of one, like if I take the graph of cosine and I transform it in a specific way, I get the graph of sine, and vice versa. Okay, so this one's another one we're going to do graphically. Let's take with the first one. Sine of x equals cosine of pi over 2 minus x. Sine of x equals cosine of pi over 2 minus x. Now, I'm going to prove this identity by actually graphing cosine of pi over 2 minus x and showing that the result is the graph of sine. Okay, so while the identities won't be on the exam, okay, this is going to be an opportunity for us to refresh ourselves on graphing because that will be on the exam. Okay, so I want to graph a cosine function. Okay, what are my boundaries for the compound inequality? Fawaz, help me out on that. For cosine and it's sine as well. Remember, it's less than or equal to what? What's the boundaries, the upper or the lower, for my compound inequality if I want to graph cosine? No. No. I think you're thinking about the inverses. We're trying to graph. So the lower boundary for cosine has to be 0. The upper boundary is 2 pi. You guys remember this? We did it on a quiz last week. It'll ultimately give you the period, but you were saying, you said 0 and 1 and 1 and 1. Okay. All right. There we go. Yes. Yes. Absolutely. Okay. So let's go ahead and review a little bit. Okay. What are the upper and lower boundaries for sine? 0 and 2 pi. They have the same boundaries. Now, what about cotangent? 0 and pi. What about tangent? Ooh, not 0. Negative pi over 2 to pi over 2. Remember, for tangent and cotangent, you have to use consecutive asymptotes. Okay. What if I wanted to graph a secant or a cosecant graph? What are my upper and lower boundaries again? It is 0 and 2 pi because we graph secant and cosecant by graphing the reciprocal sine and cosine. You guys remember that? Okay, we may want to go back and review because based on my answers, I'm not thinking we're really remembering that. Okay, remember we just had a quiz on that last week. Okay, so Stephanie, help me out. What is going in between 0 and 2 pi? There you go. Whatever's in parentheses, remember that's my horizontal transformation, we're going to put right here in the middle. So pi over 2 minus x. Okay, now what do I want to do once I've got my compound inequality? We want to solve for x. We want to get x by itself. So the first thing I would do is subtract pi over 2. Okay, so 0 minus pi over 2 would be a negative pi over 2. Pi over 2 minus pi over 2 would just leave me negative x. And what's 2 pi minus pi over 2? 3 pi over 2. Now, I'm going to have to do one of two things here. I either have to go ahead and divide through by a negative 1, or I got to multiply through by a negative 1. But what is going to happen? There you go. Remember, if you multiply or divide a inequality by a negative, it reverses your symbols. Okay. So if I go ahead and divide through by negative 1, that's going to give me pi over 2. There's my positive x. Negative 3 pi over 2. But those less than or equal to now become greater than or equal to. Okay. Now, we've simplified the compound inequality, but we always like it to go from least to greatest. Here we start with the greatest and we end with the least. Now, the statement is still true, but I'm going to go ahead and rewrite it So it looks like this. Negative 3 pi over 2 less than or equal to x less than or equal to pi over 2. Now, those symbols only reverse themselves once when I divided by the negative. It looks like they reversed again when I rewrote it, but they did not reverse. Okay. Does anybody want me to elaborate on that? Both of those statements are saying the exact same thing. Everybody's okay? Okay. So now I got my x's. Okay, we're going to put that to the side. Well, how do I figure out my y values? What do I do? Okay, critical values, but we're trying to graph cosine. So remember, cosine started with a maximum, 0, -1. There we go. Okay, so do we still know the critical values for the other trig functions? Okay, Satish, what are the critical values for cotangent? Undefined. Oh, 1, 1, 0, -1, and then undefined. Okay, tangent goes undefined, -1, 0, 1, undefined. Okay, make sure we know those. Okay, we definitely need that. Now, what's happening vertically here? What's outside the parentheses? Okay, anything outside the parentheses? Nope. So in this case, those critical values are going to stay the same. Okay, so how do I pair my x's with my y's? How do I get those ordered pairs? What's that? How do I now get my ordered pairs? How am I going to put the x's and the y's together to get those?
You put the -3 pi over 2 on that side.
Okay, so the lower boundary goes with the first critical value. Upper boundary goes with the last critical value. And then there's something we always do. Divide what by 4? That thing.
Yeah,
There's a lot of things up there.
the pi over 2.
Pi over 2?
Yeah, you have to, like,
Now, if your lower boundary is 0, yes. How far is it from a -3 pi over 2 to pi over 2? How many radians?
it is. Oh, no, yeah.
2 pi, right? From -3 pi over 2 to pi over 2, we can subtract those. Okay. Now, if your lower boundary remains 0, then you take that upper boundary, you always divide by 4. If it doesn't remain 0, you have to find the difference, which is the distance, and then we always divide by 4. Okay, I am somewhat alarmed at this point. Okay, a lot of people do not seem to be remembering things that we spent a lot of time on, and your test is in days, and some people are failing, so I'm alarmed. Okay, who has not started studying for this test? Okay, please study for this test. Take some time and look over the material. Get with a study partner. Go for tutoring. Yep, I'm here. Please. Okay, now what? What is 2 pi over 4? That's pi over 2. Okay, so what am I going to do with this pi over 2? I'm just going to add it over and over, starting with the lower boundary. So what's -3 pi over 2 plus pi over 2? That is negative pi plus pi over 2. Negative pi over 2 plus pi over 2 plus pi over 2. And should we always hit that upper boundary exactly? Every time. If you don't, we've made a mistake someplace. Okay? So here are my ordered pairs. Now let's go ahead and graph it. So pi over 2, let's say that's pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, -3 pi over 2, -2 pi. Then I have a maximum and a minimum. Okay, so the first one is -3 pi over 2, 1. So I'm going to go left 3 pi over 2, up 1. Then I have negative pi 0. Then I have negative pi over 2, -1. Then I have 0, 0. And it looks like I'm finishing with pi over 2, 1. So that definitely looks like cosine. You're going to have that curvy V right there. But how can I get more of this graph? What can I do? Yeah, just repeat the pattern, right? So after this maximum, what would come next? 0, then a minimum, then another 0. All right. You do it in the other direction as well. Now let's connect my points. Now that is the graph of cosine of pi over 2 minus x. But do you notice anything else? That is what? That is the graph of sine. That's his parent. Okay? That's what we're talking about when we say cofunctions. Okay? If I transform one graph, I should get its cofunction. So if I did the same thing to sine, if I graphed sine of pi over 2 minus x, I should get cosine. Okay? If I were to go ahead and take cotangent of pi over 2 minus x, if I graphed him, I should be getting the original graph of tangent. Okay? And you can do the same. You can just go ahead and graph, the rest of those. And maybe to work with the identity and get a little bit of practice for the exam, not a bad idea. Go back and see if you can graph some of those. Okay? And if you do run into trouble, come on in, let me help you. All right, so there are all the identities. There are quite a few, and you do need to know those. You do need to have those memorized. I hate to use that word, but you need to be very, very comfortable with those. Okay, let's go ahead and start looking at some expressions here. Now, I look at these problems as a game. Okay, let's say you're going to sit down and you're going to play a game. Well, how do you play a game? You have to know what? You've got to know the rules. If you know the rules, then you can play the game. Well, these are our rules. And this is what's going to be difficult for some students. Can you solve expressions using different identities? Yes, there's not going to be just one way to work these problems. So it really just depends on what you first recognize. Okay, so that's why you have to be really comfortable with these identities here. All right, so let's take a look at our first one. It says, if cosine of theta equals 3/4, find secant of theta. Okay, now some of these are listed, and then I've got one that's not listed. In fact, we'll look at that one in just a second. But what identity could possibly help me out here? I have cosine, but I want secant. Yeah, reciprocal. Okay, we have a reciprocal identity that says secant of theta is 1 over cosine of theta, right? But we are given cosine of theta. So 1 over cosine is actually 1 over 3/4. And what happens when you divide by a fraction? You multiply by its reciprocal. So secant should be 4/3. Okay. Sometimes they're going to be very straightforward. Sometimes it's going to take multiple steps to get what you want. Okay. Let's try this next one. If secant of x equals 5/4 and tangent of x equals 3/4, find sine of x. Okay, so Satish, I need an idea. How can I go from what I have to what I need? Okay, so now there's something we need to do before that. Okay, let's go ahead and use the reciprocal. Because we're given secant, so that means we should immediately have what? Cosine, right? Because cosine of x is equal to 1 over secant of x. So just like we did a moment ago, this is 1 over 5/4. So cosine should be 4/5. Okay. Now what Satish is saying, since we now have tangent and cosine, let's go ahead and use the quotient identity. Another identity we saw was that tangent of x is equal to sine of x over cosine of x, right? Okay, well, what's tangent of x? 3/4, so I'm going to replace that trig function, equals. We're looking for sine of x, and we just found cosine to be 4/5 by the reciprocal identity. Okay, now if I go ahead and solve this, we're going to end up with what we need. Okay, now a lot of people are probably going to want to go ahead and multiply by the reciprocal, but see, that's not going to get rid of the fraction. It's still going to be on this side, and we just need sine of x. So in a case like this, I would probably just go ahead and say multiply through by that denominator, even though that denominator is a fraction, because what's going to happen? Yeah, the 4/5 are going to cancel. And what's that, Christian? Sine of x is now isolated, and it's equal to what? Sine of x equals 3/5. Okay. Questions? Now, here's the thing. I want to go ahead and get out in front of this because people in other classes have already been asking me this question. Okay, why do we have to go through all this work when we could just do this? I'm going to draw a right triangle. Let's say this is theta. Remember, tangent is y over x, right? So y over x, this is a 3, 4, 5 right triangle, so sine of that angle should be 3/5. Right? Was anybody out there wondering that? Okay, here's the thing. We don't want to fall back on those triangles. We don't want to look at the diagrams anymore. We want to use those identities. Okay, you need to be as comfortable as you can with those. Okay, now if you want to go ahead and draw yourself a diagram, I would say it's only okay once you're done with the problem and you want to check your answer. Okay, but don't use the diagram to just go ahead and give me the answer. You have to use the identities. If, say, on a quiz or something, you draw a diagram, but there's absolutely no work, you're not going to get credit for it. Okay, you have to use the identities. Everybody understand that? Okay, so I wanted to go ahead and get that out there. Now, let's try this one. This one's not as straightforward. I'm given secant of theta, but I want to find sine of theta. Now, I'm going to give you 2 minutes to try this one, and I'm going to go ahead and give you a hint. An identity I used came from the category I said was going to be most important to you. Okay, so let me give you 2 minutes. So we're using an identity from the category I said was going to be the most important to you. Okay, that's 2 minutes, and you may not be completely done. That's fine. By show of hands, how many people believe they know what sine's ratio is? What's the final answer? So only seeing a few hands go up. So Connor, why don't we start with you? What do you say the answer is?
12 and 13.
He says 12/13. So what do you guys think? That is absolutely right. Okay, now Connor, walk me through. What'd you do?
Okay, so first I used it like that. Sine squared of theta plus cosine squared of theta equals 1.
Okay, good.
And I took the reciprocal of secant, so that's 5.
Okay. So we know cosine of theta is equal to 1 over secant of theta. And I'm just going to go ahead and skip a step here. So yes, it is 5/13.
And then I squared that out.
There you go. Now it was just a matter of substitution. Very good. So sine squared of theta plus. Now, we're replacing cosine with 5/13, so the operation is still going to be there. So this is going to be 5/13 squared is equal to 1. You're just replacing the trig function, not what's happening to the trig function. Okay. Jane, what is 5/13 squared? Ooh. 169, there we go, is equal to 1. And then, we're just solving an equation here. So sine squared of theta is equal to 1 minus 25 1/69. And what's your common denominator? It's got to be 169. So this would be 169 over 169 because that is 1, right? 169 minus 25. Okay, that would be 144 over the common denominator 169. Now, if I had x squared and I want x, what would you do? You just take the square root. The same rule applies to your trig function. I have sine squared, but I want sine. So I'm going to take the square root. So we see that sine of theta is the 12/13 that Connor told me about. Now, how many people got that one right? Okay, so I'm curious. Nowhere near that many hands were raised when I said, okay, who has the answer? Okay, you got to have confidence. Even if you're wrong, so what? How many times have I stood up here and been wrong? Oh, whatever. I've made a lot of mistakes. Okay, it's going to happen. Can't be afraid of failure. Okay, so you got it wrong. Let's talk about why so it doesn't happen again. Okay, have confidence. Okay, that is as far as the other two classes made it, so we are going to stop there for today, and we will continue this tomorrow. Okay, if you have not started studying for the test, please do so. This test is going to determine if some people pass the semester or not. It is very, very important. About what, sir? This one? If I do, there should be some over there, unless all the copies are gone.